Hello, do you hear me?
Yes, of course. How are you,
Good.
Dr. Acha?
Morning.
Morning.
Morning, Dr.
Hello,
Acha.
do you hear me?
How are you?
Do you hear
Yes, we
me?
can hear you clear.
Of
No.
course.
Oh my.
Your sound is very clear.
Volume.
Okay.
Mute your speaker.
Okay, yeah.
The
Your sound
volume.
is clear.
Do
And
you hear me still? Do you hear me now?
yes, of course.
Okay, great.
How are you?
I'm good, thank you. I'm
Yeah.
on the way to work, but
Yeah.
I will reach my work in around 12 minutes.
Wow.
But anyway, my husband
Okay.
is driving. Okay.
And you
So,
drive by yourself? Are you
What's that?
driving by yourself?
No, no, I'm not driving. My husband drives.
Okay, okay.
Yeah.
Thank you. Be careful.
so Erni,
Yeah.
you will be the first speaker, I think, because
Yeah.
Dr. Raja is still
It's still on the
on
way.
the way.
Yeah.
Okay, so Erni will be the first, and then Dr. Acha, and then Pak Agung.
Okay. It's never mind.
Okay.
Thank you.
Okay.
Yeah.
How do I change my background, Ernie?
Okay, it's very simple, Dr. Acha. By click on the right side of the picture with camera, and then you choose the background. But you must download the background first. Maybe committee, please help Dr. Acha to send the background.
Okay, and where is the thumb? Where should I click?
In the right side of the picture of camera, you
I see camera picture.
yeah, there is an arrow. There is an upward arrow, and you click the
choose virtual background. Yeah.
yeah. Oh, the picture of the background. Please, Mas Satria.
Okay, I got that. Yes, yes.
Please help Dr. Acha to send the background, please.
I think the background has been uploaded in the chat feature. Please check in the chat feature, Dr. Acha.
Dr. Acha,
Yes.
the picture of the background has been sent to the feature of chatting, and you.
I see. Let me look at the chat.
Okay.
I see. All right, I found it. Load.
Thank you.
Okay, and then I change the setting. All right.
Successfully changed your Congratulations.
Thank you very much. Thank you very much.
You look nice. Okay. Successfully changed the background. Okay.
Yeah.
So you are ready now to
Yes.
to be a speaker. But actually, the moderator asked you, Dr. Acha, to change your position as a second speaker because he thinks that you are on the road to your office.
Okay. I think it's better. Yes. Yes.
Okay. Yeah.
Yes.
Thank
Better.
you.
Yes.
Thank you.
Thank you.
Dr. Acha, Nice to
Yes.
meet you.
Nice to meet you,
I'm
Agung.
Agung Dwi from Diponegoro University.
Hi, nice to meet you.
Thank you.
Dr. Agung has research similar with us, Dr. Acha, about the green building.
I see.
Yeah. And he teach about the and he will present about the material of UPVC
I
in
see.
the third speaker today. So
Mhm.
we can learn about it from him, and we will see about what he presents about.
Okay. So I will be the second speaker, which is around 9:05, right? 9:05, and
Yeah.
until 9:25. Yeah. And then after that, can I come back for the second Q&A session? I think you have Q&A session. I don't know how do you plan, like once the first three speakers together and then Q&A at the same time before the second session? Oh,
Yes, we will have the first session for 3 speakers.
okay.
So 20 minutes for each speaker.
Hmm.
So it is estimated that the question and answer session will be about 9:30.
Okay.
So for question and answer time for the first session is about 9:30 until 10.
Okay.
We hope. We hope.
Okay.
So,
Then I could answer. I could finish my session and then I wait until the Q&A, right?
yes.
Okay. Yeah. Because
Okay.
okay. All right. All right. Yeah.
Dr.
So
Acha,
after my Q&A, I won't be able to listen to the fourth and the fifth speakers. Is that okay?
It's okay, we think. But
Yeah.
if it's you have an available time, please join us.
Yeah.
yeah. If you much more
Until
time
the
to
show.
join us, Dr. Acha, if you much more time, if you have much more time to join us, please join
Yeah.
us until the webinar finish.
Yeah. Actually, I could attend half morning because I have a studio presentation today too. Yeah. The
Okay,
same day. Yeah.
it's okay. We understand
Yeah.
you for your busy
Yeah.
schedule.
So what is
Okay.
the topic Professor Ichiro will be speaking with today?
He will be speaking about the title is Recent Movement of Urban and Architectural Design for SDGs and
I see.
ESG,
Mhm.
because he's the chairperson of a prefectural committee for energy efficient mitigation and adaptation
Mhm. Mhm.
change. I think that's one of his topic that he is going to share with us.
Okay.
Mm. He also have a tight schedule. Uh, he only available in the break time today. So 10 o'clock until 11 o'clock. It's 12 o'clock in Japan until 1 o'clock. So it's a break time there. So he will also join us at that time.
I see.
Erni, I think it's already 8:38.
Okay, it's better if we start now, Pak Edu.
Yeah.
Okay, Mas Satria is has entered us in the plenary session. Maybe you can start now. Yes, maybe Bu Yuli, please turn on the animation first.
Oh, I'm so cute.
Okay, shall we start now?
Yes, please, Paidu.
Okay, thank you. The Honorable Dean of Engineering Faculty, Universitas Diponegoro, right now represented by the Head of Architecture Department, Dr. Agung Budi Sarjono, and ladies and gentlemen, good morning. Welcome to the third ICSADU 2020 series, hosted by the Department of Architecture, Faculty of Engineering, Universitas Diponegoro. Thank God that we could meet this morning in this great event and in a great condition. So today is the third series of the last series of the ICSADU 2020 series. So we already held the second and the first series several weeks ago. And today we will have the third series with the theme of green building towards sustainable and survivable architecture for future generation. There will be 5 great speakers for today's event, thanks to Professor Junichiro Tsutsumi from University of the Ryukus, Japan, and Dr. Acharawan Chutarat from King Mongkut University of Technology, Thonburi, Thailand, and Professor Erni Setyowati from Universitas Diponegoro, and Dr. Eddy Prianto from Universitas Diponegoro, and Dr. Agung Dwiyanto from Universitas Diponegoro. I believe that we will learn many things from what will be shared from the speakers today. Before we begin our event, I'd like to invite all of the audience to take a moment for prayer so that this event could be conducted smoothly and could give benefit for all of us. Please take your time for prayer for a moment. Amen. Thank you. So, to begin today's event, I would like to invite the Dean of Faculty of Engineering, Universitas Diponegoro, right now represented by the Head of Architecture Department, Faculty of Engineering, Universitas Diponegoro, to give his speech and to open the third ICSADU 2020 series. Please, Dr. Agung Budi Sarjono,
Thank you, Baidu.
Please give your speech for us and open this event. Thank you.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It is a pleasure to meet at webinar for ICSADU. This is the third series that takes the interesting theme, green building towards sustainable and survivable in architecture for future generation, which will feature 5 speakers. So our thanks to all of speakers, Dr. Acharawan, Prof. Ichiro, Prof. Erni, Dr. Eddy, and so Dr. Agung Dwiyanto. And also for moderator, Dr. Eddy. So also thanks to lecturers, alumni, and invited guests for within and outside the country for their participation. the committee and all related parties to their hard work so that the event can be organized well. I hope this interesting theme will bring many benefits for us in understanding architecture. And in the future, this is cooperation can be increased and provide great benefits for all. Thank you. And officially, I open this theme by say Bismillahirrahmanirrahim. Thank you.
Thank you, Pak Agung, for giving an opening speech and to open our event. Next, we will have the session of presentation and discussion. There will be two sessions. In the first session, we will have 3 speakers, and in the second session, we will have 2 speakers. And we will begin the first session, and the speakers are Dr. Acharawan Chutarat from King Mongkut University of Technology, Thonburi, Thailand. She graduated from MIT for her PhD in 2001 and Master of Science in Architectural Engineering in 1994 from Bachelor of Architecture from Chulalongkorn University in 1991. Her research area is green building, especially in energy efficiency and lighting, and also visual perception. Today, Dr. Acha will share with us her presentation entitled Healthy Green Building. The second speaker for the first session is Professor Dr. Erni Setyowati from Universitas Diponegoro. She graduated from Universitas Diponegoro for her doctor, master, and bachelor of architecture. And her research area is nanomaterial, materials made from waste, and acoustic material and brick material. And Prof. Erni will deliver her presentation with the title of Nature, From Nature to be Green, Material for Architecture. And then the third speaker for the first session is Dr. Agung Dwiyanto from Universitas Diponegoro. Pak Agung graduated from Universitas Diponegoro for his doctoral degree and master degree from ITB and Bachelor of Architecture also from Universitas Diponegoro. He has the research area in building technology, and he will share with us his presentation entitled Towards Sustainability and Survivability in Building Construction, UPVC as an Alternative Material to Disaster Mitigation of Shelter Structures. So each speaker will have time of about 20 minutes. I think we already left 10 minutes. And we will have a time for question and answer after the 3 speakers deliver their presentation. So for the first speaker, I would like to invite Prof. Erni to deliver her speech. Please, Prof. Erni.
Okay, thank you, Dr. Edward, to invite me to present our topic of material with the title of From Nature to the Green Material for Architecture. I'm going to share the presentations first. Are you joining the presentation? Do you could you see the presentations?
Yes, we could see your.
Okay, thank you.
Okay, we saw your picture. We see your picture.
Okay, thank you. Okay, ladies and gentlemen, the Honorable Dean of Faculty of Engineering, which today represented by the head of architectural department and college students who concerned with the topic in this third series webinar of the fourth international conference on sustainable architecture, design, and urbanism. Yes, sorry. Okay. I'm going to convey our presentations entitled the From Nature to be Green Material for Architecture. And we have the background and resources about the natural fiber-based material is that natural fibers play a significant role as commonly used materials, and acoustic material is highly demanded in the architectural sciences due to its application in building in which sound performance criteria are significant factors. The lack of why? Because the lack of acoustical material in building causes acoustic defects, which influences people acoustic discomfort. And you can see in the screens that the Indonesia is very rich in natural fiber. There are natural fiber plantation everywhere. Although biomass fibers and other porous materials play important role in the acoustic sciences, most of them is brittle, flammable, and susceptible to mold, weakening in mechanical strength, as well as lack in long life durability, because they can lack in durability and brittle, flammable, and has porous material, so the relative humidity can easily enter to the materials. And you can see in the screen that my research is in the area of the natural fibers, covering Econia crassipes, locally called enceng gondok, and usually called as water hyacinths, and then of coconut fiber trees, and then hemp and kenaf. And the Eugenic crassipes cause the swamp area sedimentations because this plantation is growing fast and sporadic. For example, one pieces of Eugenia crassipes grows fastly and sporadically to become 600,000 species within 8 months. It's very terrible growing of the plantations and make the swamp area sedimentations and degrade the water conservation area. The pictures describes about the Rawapening area, which has a lot of water hyacinth plantations. And the goals of the natural fiber-based materials, firstly, is finding new innovation on surface design governing to improve acoustical performance of natural fiber, finding new innovation on composing material with natural fibers, finding a new material having a high durability and high performance on acoustics, because most of natural fiber-based material are inflammable, perishable, and withered. This current research presents an alternative material with high durability, even though tough, but have a uniqueness in performance. And the research methods we use absorption performance referred to ESTME 1050-98. with the impedance tube test procedure using 2 microphones and observe the sound energy touching the materials, and we measure the absorption performance of the materials. And secondly, about the insulation STL performance, refer to STME 2611 to determine the sound transmission loss with the BNK impedance tubes equipped by 4 microphones to observe the insulation performance of the materials. And the next screen, you can see the several output of our research from nature to be green materials. The above pictures shows about the cocoa husk panel to be used for acoustical panel in buildings, and the below figures shows about the hexagonal ceramics, which made of made of clay composing by the eukaryotic cruciferous or water hyacinth fibers to make the ceramic more porous, more absorbs the sounds effectively and efficiently. And what are the innovation of the hexagonal ceramics made of clay and water hyacinth fibers? The innovation is that on the surface design. The surface designs has an innovative design by the tiled cavity. The tiled cavity is the cavity look like tadpole tail. So the sounds will be easily trapped by the materials and reduce the sound intensity in the buildings. And the next screen describes about the application of the hexagonal ceramics in the wall in the buildings, especially for the conventional buildings, which needs strongly about the acoustical performance in buildings. And the next is about the manufacture of the hexagonal ceramics in the factory, because in this research we collaborate with the industrial, so the material can be guaranteed in its quality. The Prianto invention relates to the sound diffuser absorber hexagonal ceramics. More specifically, this invention relates to porous ceramic containing natural fibers of water hyacinths, or in Latin, namely Eichhornia crassipes, in the form of hexagonal 2 variants with an interlock system that has acoustic capabilities as a diffuser and absorber. And for the result, it has 0.9 in absorption performance at 500 until 1,200 approximately hertz frequencies and 60 decibel on insulation performance. And we have got in the for the invention of hexagonal ceramics, we have got a simple patent registration with number S00200200128, and it is under process to be certified in the Ministry of Law and in Indonesia. And the result of the natural fibers made of cocoa husk, hemp, and fiber, you can see in the next screens. the cocoa husk material with 8 resonator in its surface and additional 10 millimeter air gap shows superiority, which reach up 0.95 on absorption performance at middle frequencies. And secondly, the 15 millimeter K-knife material with one tiled cavity, you can see in the continuous black line in the graph. The 15 millimeter K-knife material with one tiled cavity in its surface and additional 10 millimeter air gap becomes prospective material due to having good absorption performance at low frequencies. And thirdly, you can see in the dash dot black line in the graph, the hem material with double tiled cavity innovation on its surface shows prospective performance also, but lower than the previous two materials. And the next screen, you can see the other materials, that is hexagonal ceramics made of clay and composing with the water hyacinth fibers, which is very abundant in Indonesia, especially near the Semarang city, in Ambarawa city. And we have tested the materials, and the results becomes in the upper pictures, you can see the absorption performance, which has average absorption coefficient at 0.3 at the low frequencies. And the lower pictures describe about the insulation performance of the hexagonal ceramics with the average 58 decibel for the wide band frequency. It's very sophisticated because to have and to reach the wide band frequency performance, either in absorption coefficient and insulation is very hard for the material, and this innovative material of hexagonal ceramics has a wide band frequencies for the insulation performance. Yes, I think it's very important for the acoustical material. And in the last pictures, you can see firstly application in architecture. The upper figures describe about the implementation of the acoustical materials in the building as a wall panel, who people can usually apply in the buildings, especially in the conventional building. And the upper figure shows about the hexagonal ceramics, which has 8 resonators and have space within it to trap the sounds effectively and efficiently. And the conclusion of research is that Indonesia has an abundance of natural fiber which yet has been explored at all. We must consider several conclusions regarding how to manage material from our nature to be more useful for human beings. Firstly, most of the natural fiber-based sound absorptive materials are inflammable, weak in mechanical strength, and have lack of long life durability. For examples, cocoa husk, hem and fiber, they are all inflammable, lack of durability, long life durability. And secondly, we must think and consider to make innovation on how to create strong natural fiber-based material with a number of novelties on it. Yes, it's very important for the research. Every research should have novelties in their scope or their area. And certainly a partnership between academic and industry is the most important key to establish the teaching industry, because Universitas Diponegoro has developed the teaching industry, and one of the teaching industry is the hexagonal ceramics, collaborated by the industrial sector. And fourthly, innovation for natural fiber-based material without industrial partnership is hard to be developed, of course, due to the quality aspects. Cases of cocoa husk, hemp, and canvas, as well as sawdust, we have not made a collaborative partnership with the industrial. So the output is stacked and undeveloped. And unlike the cocoa husk and other fiber, the hexagonal ceramics different, because we have developed the hexagonal ceramics by collaborating with the industrial sector. So the porous ceramic has been proven as prospective material for acoustical appliance in buildings. And at the last, there is the message for you all. Thank you for attention and response. Message for green material: reduce the emission, green the environment, avoid the water conservation of swamp area sedimentation, and save our earth for future generation. That is all our presentation. Thank you, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Bu Erni. Save our earth for future generation. That's very important. Okay, we will. If the audience have a question for Bu Erni, please keep it first, and we will have the question and answer later. So speaker, I would like to sharing with us your presentation. Dr. Acha.
Yes, thank you very much. I'm going to share my screen. Yes.
Yes, please. Thank you.
Okay. Okay, now everybody see my screen. Okay.
Screen.
Okay, good. I'm gonna start talking at the moment. Thank you very much for inviting me to the ICSADU, the fourth ICSADU, and today my topic is about healthy green building design in tropical climate. So I'm gonna have two of the sections of my presentation. The first is the findings from our Acacia Committee on Green and Sustainable group, and the second section is gonna be my work, my real work as a case study for the healthy green building design. So actually, today is the new urban agenda, especially around Southeast Asia, is dust pollution, where actually we really concerned on the effect of it, since it costs a lot because of asthma that we the people in Bangkok develop symptoms, and also the loss of the income from tourism industry, as well as the people, they don't go out that much during the winter season where there's a lot of dust. And also everyone really concerned on the current situation of COVID-19, where we have to think what can be done in architectural professions for healthier and flexible building design. As well as many of you have seen, many of us have seen that very rapid change in global warming effect. Okay. So to link to our consumption, where our consumption really affects the environment. For example, when we consume clothes, of course, it affects how we crop and grow the cotton. Where produce cotton in India, it caused the deforestation, and animals, they don't have much place to stay, as well as the same situation as mobile phone, where animals that don't have place to stay because of mining of the mine business that invade rainforest, as well as napkin, what we use, consume trees, deforestation, and cause global warming. And of course, finally, we have to think about waste. So in this, it comes to my own direction and my passion on sustainable development, where everyone could help. Otherwise, it will hurt ourselves at the end. So I wanted to share with you the findings from the workshop among Acacia. Acacia is Architect Regional Council of Asia, and I'm the chairperson for Committee on Green and Sustainable Architecture. So we came up with several countries, like around 16 countries, and we come up with emerging issues related to sustainability. Okay, the first is heritage and vernacular. We should look back at our old wisdom, how we can renew and adapt our old wisdom into the new direction, into future vernacular. And these are the concerns from our working group. This is the report on November 5th last year, where I have compiled the needs and emerging issues from our country members, where we have to think about sustainable tourism and eco-village. We have to think about how do we do renovation construction method, and utilizing our traditional wisdom, our old wisdom, adopting the green issues into the design. And these are example work in architecture, where we call for a green building design from different countries. And these are some direction on the new vernacular architecture from Nepal, Thailand, and Vietnam, where we can see that how design express the local materials and local climate. Next is next pillar is the finding of the new urban agenda, where we think about how, smart and technology, also green building rating tool, as well as health and well-being. And so we thought that that is a need on the developing of the new design guidelines for smart cities, smart building, net zero energy buildings, and how we should promote. Actually, ICSADU is a very good one that match our directions to promote technique, technology, new green design paradigm, and SDG development, as well as to improve awareness. Then the last pillar is the resilience. How our building design is not only green, how are we going to cope with flood, earthquake, landslide, disaster, water scarcity, and air quality? So these are our concerns, that we should develop something that many countries can use as a guideline. For example, design for flood, for tsunami, for coastal resilience, and things like that. And how are we going to design for sponge city and design for water shortage? So these are also the new urban green typologies that we collect from our country members, where they have integrated green design technique, and we can see if urban green is very trending in our Asian countries, as well as we can see the integration of new technology into the architectural design, as we can see in Thai architecture, Chinese, Japanese architecture. And so I want to come to the connection to my second section, and how do we think of those kind of directions into collaborating into design. So with respect to healthy living. So first we think about the urban heat island effect. How do we do in urban scale? And also think about architectural design, orientation, passive design, where I will give my own work as an example, how design, materials, water, and energy efficiency related into the healthy living. So actually, before that, I want to share Thai Green Building Institute work, where we draft, this is called SUK, or Health and Well-being Manual, Health and Well-being Design Guideline for Thai people. We have 4 categories. First is outdoor, where I mentioned about how we can incorporate biophilic nature in the design, green, and good air condition. Second is architectural design strategies. Third is interior design as well as materials. And the fourth is the environmental system and engineering, where we have to think about all the building performance on thermal comfort, air quality, and noise, and so on. So next is gonna be, okay, this is what we should do in urban planning, that we think about wind directions and how it affects our site, and think about how those can be utilized to fulfill thermal comfort, where we can shift our wind velocity in order to achieve thermal comfort. Especially in tropical climate, we have high relative humidity, where the comfort can be raised up by having more ventilations, more wind speed. So this is gonna be my work that I wanted to show, to share with you. It's called Project Edge. It's the under construction process, and it's gonna be finished in the next month. Okay. And if you guys have a chance to come to Thailand, I'm sure that the building will be finished by then. And you are more than welcome to visit the building that I designed. Okay. So this one, it will host 250 occupants as an office buildings. And we have to design for the growth of the building for 300 people or 350 people. Totally, we have around 6,000 square meters, and the top 3 floors gonna be for office, and the first floor, second floor, and third floor is gonna be for the public, which is more like for learning issues, and for commercial rent, for co-working space, canteen, and multi-purpose spaces. So the criteria is for, of course, energy efficient and good indoor air quality. And we would like to achieve the GNB, which is German Green Building certifications. So first, we have very limited site, which is the long, like north and south orientation. Of course, it's not the perfect one that we wish. And therefore, how are we going to design to protect from sun radiation on east and west? So we try to design the zone on the west that has the core of the building, such as the restroom, ASU, lift core on the west of the building. And on the east, of course, we have less opening. How are we going to have more daylight without heat? So we made more holes and more perimeter zone for the building in order to achieve natural light. And of course, to the south side of the facade of the building, we decide to be the parking, and we put the solar cell on the top of the roof. And we decide to have green area on the south in order to low ambient temperature. And then these are the big picture that we try to connect first to third floor by having connecting for natural ventilation and light. And fourth to sixth floor is the private office where we decide to have closed active system, no natural ventilation. But of course we have connecting for lighting from the top for connecting activities and for having biophilic, which is general trees and plants in light into the fourth to sixth floor. And so we have waterfall on the first to third floor in order to reduce ambient temperature by evaporative cooling technique, as well as we have green building facade integrated with trees for nice shade and shadow and less glare. All right, and for architectural design, like I said, I have more solid on east and west, where we want to have more natural light, indirect light. So we have green area in order to filtering light, and of course for better in psychological effect, we call it biophilic design. We have green area. And then for building envelope, we try to have different shading design options and glazing material, roof and wall materials. We have done a lot of simulations in order to find the best life cycle cost in the long term. Of course, we didn't specify the cheapest one and not the most expensive one. So we try to optimize in order to achieve good lighting and good energy efficiency. So this one we designed to, we made simulation compared to conventional box, and of course our design. And we have a better daylight factor and less solar exposure for our buildings. And also we compare about energy consumption. Of course, the third, our scenario has the lowest energy consumption. And so this is the detail of why we decide to have the openings for the green, of course, for the view outside and for the nice working environment, as well as to have natural light from the top of the atrium. And we put solar cell on the rooftop to generate 108 kilowatt for the buildings, okay? And of course, we need to think about the maintenance, which is very important in order to ensure that all the system works very well. These are the interior. We select the low VOC materials. And what is low VOC? We have our experts in indoor air quality to do the kind of surveys on 17 office buildings in Bangkok. What they found is the 3 groups of VOC that comes from office furniture. Second comes from dry clean garment or carpet cleaning agent. And the third comes from air fresheners, office cleaning agents, and worker perfume. Amazing. And another finding is that the interior, it has more VOC than the exterior. And that's how we wanted to achieve, okay. That's why we, okay, they done some kind of a survey. The symptom is headache and eye irritations. And we have done also the plant, what kind of plant that can absorb the formaldehyde. And so we tried different kind of plant, and we found out that the Boston fern has the best strong absorption properties compared to others. So we plan to have the inside, grow the Boston fern inside the interior for better indoor air quality. And next is a system for comfort and water and air quality. We also have the natural ventilation, like I said, from first to third floor. We also have collected the air handling unit, the condensate water from air condensing unit. So we collect in the tank and we release it to our garden on the third floor, which is the open air, and it's the co-working space in the canteen. So people can enjoy cool ambient temperature and enjoy planting their own food and plant in order to screen out for nice visual comfort without glare. So this is more like a kind of integration design for natural ventilation and plant and systems. We also increase the operation temperature, and we increase the wind speed by the fan on both spaces, offices and public space, in order to improve air quality, ventilation, and comfort. We make sure that we have our own food. The companies try to have their own trees and plants, so that we make some simulation to put wherever it has the good solar radiation for the plant. And finally, we think about maintenance. Without the good maintenance for plant and for sanitary system, for air condition, we don't have a good healthy building. Since we need to clean it, we need to ensure that we have enough space for ducts, sanitary duct space. And these are for air conditioning unit, and also for the facade, for the green facade. And also last is we need to promote the green and sustainable. So we decide to have the learning center in the lobby, where people can learn from us, to learn different type of air conditioning systems, like radiant cooling floor and dedicated outdoor air system, where it cool down the air by reducing humidity before entering. This is a very energy efficient systems. And finally, we see that our performance expected to be around 110 kilowatt hours per square meter per year. And it fits with our Thai roadmap for 2030 that we try to reduce. This is the reference for office building in Thailand at the moment. And this is the building energy code. And we do far much better than the building energy code and high energy efficient performance. And for the DGNB, we will get the DGNB Gold certificate. Finally, we try to use the AI, the Internet of Things this is the app that we also designed to capture how they control lighting and temperature. And future, we will learn the pattern, how they use, where they are, and hopefully to learn at the artificial intelligence as the next step of my research, in order to see what are the best control for indoor environment. So in conclusion, the direction that we think that we should go is somehow something that we could connect to our old wisdom, our new urban agenda, as well as to stand for resilience. In my building, I put the system on the second floor. Of course, we try to avoid the flood, and we have the PV and adaptive reuse, where we design things for flexibility, for future expansion for the office building. And that's all my presentations. And thank you very much.
Thank you very much, Dr. Acha. So it's very interesting. So how to promote a healthy, smart, green building. Okay, so we hope that in the future we could visit the building that you have
just let me
developed.
know, text me. Yes.
After this pandemic over, we hope soon will be better. Okay, thank you, Dr. Acha, and we will continue with the third speaker, Dr. Agung Dwiyanto. Please, Pak Agung, you have about 20 minutes.
Okay, thank you, Mr. Edward. I'm ready to present my presentation. Okay, I'm share my presentation. The theme of my presentation was towards sustainability and survivability in building construction, UPVC as an alternative material to disaster mitigation of shelter structure. The theme of this paper is part of my research conducted with PPPT and Teriham industry. In my team in Diponegoro University is Mr. Dr. Agus Subagio for MIPA department and Professor Sri Tujono from Civil department. From BBPT is Dr. Dodi, and from Kent, Teriham Industrial is Mr. Samsunar. The Ministry of Research Technology and Higher Education also support with the PPTI scheme. PPTI is Program Pengembangan Teknologi Industri. The research starts from the attention of the PT Teriham as a UPVC manufacturer for the handling and provision of post-earthquake shelter. We all know that Indonesia is one of the countries traversed by the world earthquake route. And the last big earthquake in Indonesia occurred in the island of Lombok in 2018. On the display shown, research response and spectrum building construction on the effect of earthquake. The occurrence of the earthquake destroyed several areas and thousands of homes on the Lombok Island. One of the post-earthquake handling by the government is build shelter quickly to meet the needs of housing after the earthquake. The result of post-earthquake studies on the Lombok Island required 52,000 disaster mitigation shelter. Several agencies have assisted the government is meet this need, but in its development, they only fulfilled half of its requirement. Several alternative design and material used has been proposed, and each with the advantages and disadvantages. The display shown several alternative disaster mitigation shelter design with a construction period of more than 1 MIG at a cost and around 90 million rupiah. Okay, and PT Cherryham, as UPVC produced in collaborated with BPPT and Diponegoro University, researches the possibility and UPVC as an alternative construction material in disaster response housing with a fast and inexpensive to build. On the display shown, some UPVC material produced by the PT Cherryham industry. Goal and objective in my paper, look at the display. And Diponegoro University is handling with design issue and resident design concept. Will BPPT examine the strength of the material, and sometimes PT Cherryham provides material and corporate social responsibility program, program CSR. In architectural aspect, researching building architecture, local culture and climate, as well as community needs for post-earthquake housing, and civil part examines soil structure and earthquake behavior that occur on the island of Lombok. BPPT look at the strength of UPVC material about the strength and flexibility. The result, in the prototype of disaster mitigation shelter from UPVC material, which are not only cheap and fast in implementation, but also superior in several aspects. For example, the use of monolith joint, so they are more crowding, having high material flexibility, so they are not easily broken, terminate roof and do not spread fire, and so they are relatively safe. It is born. The condition is under the requirement of disaster mitigation shelter. On the display shown first prototype design. In UPVC material testing by BPPT refers to the RIHAU and FICA standard, but of which are Europe standard. On the display shown, testing process by BPPT is density testing, shore hardness testing, FICA softening point testing, and Sharpie impact testing. The result of the test, Cherryham product more elastic, but the strength is still below from both standard. Exploration to develop of the prototype is designed by conducting studies of traditional architecture on the Lombok Island and Indonesia in general. And use UPVC material so much as possibility, and the part of its worst. the local climate and pathway of the sun. In the picture, you can see the process of shedding the sun rays using the software in 1 year. Based of this analysis, it was found that the positive on the axle of the building was most effective with a north and south direction with a length of 100 centimeter. In the caption, construction reform and required by adding hollow iron and the safety steel stiffener is pengaku. Okay. In the display, shown the new design of environmentally friendly disaster mitigation shelter in the form of a 36 square meter shelter. The specific involving its people as field implementers. In 1 day, 4 disaster mitigation shelter units can be built. And in the late development, in testing the speed of construction, 1 resident, 1 house, 1 shelter unit can be complete in 3.5 hours. It's very fast. There are several photos of activity during the installation and implementation of model house for disaster mitigation. Look at the part of shelter to build. Okay, and the conclusion and my presentation in UPVC is an earthquake-friendly material. In the category of materials similar to UPVC, it has the advanced to light weight, strength, and fast implementation. UPVC design principle is a disaster mitigation shelter material. And the end of the presentation, I would like to show a test video for installing the 4 prototype to UPVC is on alternative disaster mitigation shelter. Okay. So no. You can see, Mr. Edward?
Not yet. Not yet.
Not yet? Oh.
Mr. Agung.
Not yet.
We still seeing your...
No. Okay.
PowerPoint conclusion.
So
maybe you can unshare first, Pak Agung. Unshare first your PPT, and after that you can share again for your video.
I'm sorry. I'm sorry. Okay.
Yeah.
Okay. As you see. Okay. Excuse me. I'm sorry.
Okay.
Thanks for your attention, Mr. Edo.
Thank you, Pak Agung. You have nice birds with beautiful sound. And thank you for sharing with us your post-disaster housing reconstruction program with the case study in Lombok with using the UPVC as the material. It's amazing that only 3.5 hours to construct one house of 36 square meter. Okay, I think it would be a very nice alternative for the post-disaster housing reconstruction program, especially Indonesia is a prone area for disaster, especially earthquake, and also in the in your video, good course, I think. Okay, so next I will open a question and answer session. So maybe we don't have much time, about 10 minutes, top 15 minutes. So maybe maximum 3 or 4 questions. So please raise your hand and please mention your name and deliver your questions. Okay. Anybody? Maybe to Prof. Erni or Dr. Acha or Dr. Agung. I think we have a very interesting materials and topic from all of the 3 speakers.
If nobody asks, I want to have some question.
Sure, Dr. Acha, it's okay. Also,
thank you very much. I want to ask Professor Agung. It's quite interesting topic. I wanted to know the structure of the house. What is the structure of the house, and what is the limitation of UPVC? Like how high, or is there any limitations of the use of UPVC, and what is the structure of the house?
Okay, structure of the house and limitation of the material. Please, Pak Agung.
Okay, limitation from UPVC.
Yeah.
I'm
maybe about it only can be applied to first only it cannot be applied to a 2nd-story house or only 1-story house or kind of thing like that. I think what Dr. Acha said. Or maybe Dr. Acha can explain.
Yeah, please. Like that. Can it be only 1 story, or can it be 2 stories? Or how long does it last? Something like that.
Only in the research for 1 story and developed to level in my building, and 1 shelter can build in 3.5 hours, and cost of building about 60 million. I think it's not expensive, because in the similar of the project in with the material, as for example, panel concrete, cost of buildings about 90 million. So this my UPVC research into building shelter, I think is very
I see. And I see in the video, I see look like a column is black. Is it UPVC or is it steel structure? The column?
No, and UPVC can support by hollow steel to
I see.
yes, hollow steel to more better
I
to
see.
impact of the earthquake.
I see.
Thank you, Mr. Acha.
Thank you.
Okay, any other question maybe from the audience?
Yeah, one question from Giska, Pak Edu.
Oh, Giska, sure. Please, Giska. Is it possible for you to turn on your camera and then ask your question to us?
Okay, good morning. Thank you for the opportunity. I'm Giska from University of Mataram. I found it's such an interesting and enlightened presentation. But I have like one particular question for Mrs. Erni Setyowati. That I found that your presentation material is so interesting. My question is there any further research that study the capability of your developed material that can be used as a structural element for building? Not just because your example is just for acoustical layer. So is there any further research that it can be used for structural? Because I see that it has like a promising opportunity to be used as a prefabricated material for building, especially like to some earthquake building. Thank you.
Okay, thank you, Giska. It's very nice question from you. Yeah. Okay. I am going to answer your questions. I think we will prepare for the research, but still in acoustical area, and we have not tried to move to other area from the acoustical area. I think because the clay so far, I know that the clay is only for the acoustical panel for building so far. So, but okay. Your question is inspired me to make further research for structural material, and maybe for the research for structural material need other collaborative industrial to involve the research, because to make structural material is different comparing to the research for the acoustical material, I think. But okay, it's nice question and inspiring me to move further for the research on structural material. Thank you, Giska.
Okay, a good question.
You're welcome.
I think Prof. Erni also conducting research about the brick material. Maybe after this, going with the structural material from I don't know what, from the water hyacinth maybe.
Yeah,
I'm
we are
not sure
trying
that's...
to.
Okay.
Yes, we are trying to. Okay.
There's a question from Rahmat Taufik to Pak Agung regarding the design. Is there any room of participation from community to develop the design? So Rahmat Taufik is asking whether you are there participation from the community to get involved in the design that you propose. Agung?
Yes, I'm not here.
Participation from community. Do they involve in the design of the house that you have?
I can to answer because in the month we can to build in Mataram and show to develop of my design to continue to propose, and I think after the build in Mataram I can to more better design and shelter to mitigation of a disaster. I think it's I hope to more better in the design and participation of my
community.
I'm not yet.
Okay. So you have involved the community at the time you try to propose the design.
Yes, right.
Then maybe it would be good getting the committee involved to propose the future design of the post-disaster housing reconstruction that you are going to implement it.
Okay.
Okay. Any other? Maybe from Pak Budi. I saw that Pak Budi is turning on his camera. I think he's going to ask something.
Okay, thank you. I want to ask for Mrs. Acha. Mrs. Acha, I want to ask you about your presentation is very interesting, and I want to know about how to make macro issue and then to start on the detail engineering like your the end of presentation in the principle of three. I think any model for detailing to issue in the practice of architectural design to apply it. Thank you.
Okay. Maybe about.
So you asked about is there
Please,
any so to repeat your questions, Budi, you asked if there is any architecture that combine all of the three into one solution.
Yes, I see like that is.
I see. I think for my building, I don't have any vernacular because it's different. It's the different context. It's the office and the owner sells air condition and technology stuff that I couldn't. So far, we are trying to compile as a kind of book from us. It's called, every year we ask for green buildings from 21 countries. We ask for submitting and then, from country representative, they select only two projects per country. So we have collected at the collective green buildings. And so far, I haven't seen the one that combined everything together yet, because the one in heritage, somehow the office building, most of them, or the one in downtown and no relate to history in that, they don't do, or the historical buildings, the renovation, they lack of something. But I hope in the future there will be a kind of renovation of the existing or something that can utilize the context of heritage, as well as new urban agenda and energy efficiency altogether. Not yet so far.
Okay, yes, I see.
Yeah.
Okay.
Okay, Mr. Eddy.
Okay.
Thanks.
Thank you, Pak Budi and Dr. Acha. Any other question from the other audience? There's one question from Erni S. Sabtaningtyas to Dr. Agung. She want to know if UPVC is fire resistant. And second question is, how long will this building last?
If the meaning of the UPVC can I think I don't know, because my friend in BPPT can analysis from material tests, and the product now can carrying this or kebakaran. Fire, yes. This is inspired. I don't know. I don't know how about this material can spread in two hours, but not falling, but only merambat to not tidak terbakar tapi merambat.
Merambat. What is merambat? Okay, but you don't know exactly how is it fire resistant and how many hours it can resist if it touched by fire or something like that. Maybe it would be a further research about how fire resistance for this material, and how long for the building could last.
What's
the durability of the building? How many years that it could be?
If not can more disaster, the building can stay at 10 years because
10 years.
of standards of the UPVC material from industry.
Okay.
Yes.
Not longer, maybe 20 or 30 years.
Yes, all right. For mitigation shelter, don't not to a permanent shelter. Okay.
So it's not meant as a regular or permanent house. It's only for in the emergency shelter after the.
Yes, right.
Okay. Maybe Rini Esaptani could ask directly to Dr. Agung, please, if you want to ask directly.
Okay, thank you. I think it's okay with the explanation from Dr. Agung.
Okay.
Okay, Rini.
Okay. One more question maybe from the audience to the three of the first session speaker, please. Is it good? Okay, so if there is no other questions from the audience, so I would like to close this first session of today, and I would like to invite you to give applause to all of the speakers. And yeah, I think that we have learned many things from the research of the speaker, how they implement their research into real things in the living environment. So before we continue with the second session, we would like to have a photo session. So would you please turn on your camera, and I think Pak Satria who will make the photo session.
Yes.
Please wait for a moment for the participants to turn their camera on. On your marks ya Pak Satria ya.
Okay.
On. Please wait. Okay, Pak Satria, it's your.
Okay. I will count to 3. 1, 2, 3.
One more.
Yes, one
freestyle.
more.
Freestyle.
Repose. 1, 2, 3. Okay, thank you. That's enough.
Okay, thank you. So thank you very much to Dr. Acha for providing your time and experience and knowledge to us and sharing with us today.
Very nice conference. Thank you, and good to hear the research from your side. And I'm glad to be a part of your ICSADU. Thank you very much.
Thank you.
So, okay. And thank you also to Professor Erni. And thank you also to Dr. Agung, who already shared with us with today's presentation. Okay, so we will continue to the second session. So I would like for the first speaker for this second session, I would like to invite for the first speaker of this second session. So Dr. Eddy Prianto graduated from University of Nantes for his doctoral degree in 2002, and DEA from ICSADU, France in 1997, CES from NTPE, France in 1994, and Bachelor of Architecture from Universitas Diponegoro in 1989. His research topic is in building science and building urban conservation. So today, Dr. Eddy Prianto will share with us his presentation entitled Reduced Scale Building Model for the Green Building Investigation of Energy Efficiency and Indoor Thermal Performance from 2005 and 2020. So it's already quite long research conducted by Dr. Eddy Prianto. Okay, Dr. Eddy Prianto, please you could start your share your presentation. Dr. Eddy, please.
Thank you, Mr. Pandelaki.
Yeah.
Good morning, ladies and gentlemen. Firstly, I convey my honor to all speakers. Secondly, I would like to thanks to the steering committee for the opportunity to share my interest in the fields of building science, especially in the green building aspect. On this occasion, I am presenting my paper, Reduce Scale Building Model for the Green Building Investigation of Energy Efficiency and Indoor Thermal Performance from 2005 until 2020. In brief, my presentation inform you about my investigation about green building since 15 years ago, the opportunity for making collaboration in green building research. The green building research is very raising is very benefit for students in doctoral or master's degree. Next. Next slide, please. Okay. My presentation consists of 4 parts: introduction, and then the map of green building investigation. In the third part is the explanation of research result during 15 years based on the actual problem found in the society. The last part includes conclusion that giving the opportunity for further development and research to solve the current problem in society. Next. We start with a question. Why does modeling investigation are very interesting? In short, it saves the time and cost. I remember the question of my dissertation examiner in France about my future research after doing my doctoral using simulation method when I back to Indonesia. In the early simulation research cost too much and was really carried out in Indonesia. Most of colleagues made research with in situ measurement and thought with a reduced model is the solution to complete the treasury in this field. Next. So far, research in building science could be conducted in 3 methods: in situ measurement, laboratory experimentation, and simulation. Next. In situ measurement is the most favorite method in my college. Refer to data collection in the field that take too much cost and time. The advantage of this method is the accurate data collected. These data are very important to validate the accuracy of simulation software. Next. Laboratory experimentation provide cost-effective means to solve the problem found in field measurement caused by microclimate such as rainfall, air movement, etc. Next. Nowadays, computer simulation has proved to be vital adjuncts to building science research that support the design and operation of buildings. Simulation model can assist the solution for microclimate problem and give the prediction for the future. Next. Okay, next, step 2. In this section, we brief a review about green building. Concept of green building is a build which the planning, construction, operation, and maintenance of attention to aspect to protect, conserve, reduce use of natural resources, maintaining and quality of both building and the quality of indoor quality and health of all occupant space on the participants of sustainable development. We found 4 keywords: the planning, construction, operation, maintenance. As far my investigation include in the first one. The second, from the 6 green building criteria, we still only just that with the aspect of comfort and energy efficient. Further investigation of building that for the criteria is still needed. The opportunity for conducting research about green building can be seen in the following table. Next. Voila. Next. The second part is a map of green building investigation with first viewer. The purpose of this study is so green building research in the world. By entering keyword of green building on www.scopus.com, we will find more than 6 million articles about green building with various aspects. The figure shows information on the outer country that dominated by China and United States and the cooperative network in investigation about green building. In the line below, shown the researches during the last 5 years. Next. The picture shows the country network, the conducted green building research. We can see Japan, Thailand, Malaysia, Lithuania. One of speakers in this webinar comes from there. It's found that there is no cooperative network between those countries. I hope after this occasion we can make any collaboration in green building research. Next. By entering architectural design as the keyword, we can find more than 800 papers and still dominated by China and United States. Adding the word of topic in the keyword of architecture design, will find 50 papers. It can be said that tropic architecture design is very interesting topic to investigate. Next. It is so the green building experimentation related to the architectural design found more than 800 papers. Therein, 210 papers or 25% use experimental method. Next. Step 3. Next. This image shows the reduced model with 30% of porosity we use in our resources. The dimension 1 multiply 1 on the round table plate that can rotate the building orientation in accordance to sun direction. Next. As far we have conducted researches about the effect of color on the wall facade, the effect of sun shining on building wall, the effect of natural stone, the effect of roof materials, the influence of roof shape, the effect of roof color, the effect of green wall, and the effect of window shape. Next. The background of this study is the importance of overhang that tends to in the current housing development. The overhang in the tropic use as building facade protection from sun radiation and also decrease indoor temperature up to 25%. It was suggested the placement overhang optimality found in the east and west orientation. The future investigation will emphasis on other variables such as air movement, rainfall, and humidity. Next. The trend was very interesting to investigate. As we know, the trend building color in 80s were white and cream. The investigation research shows that color has significant influence in reducing indoor temperature. For the city Semarang, it was suggested to use blue color for building facade that can reduce more indoor temperature than the red one. Next. Natural stone is found in Indonesia and currently used as building facade configuration. It was found that the use of natural stone on building facade configuration also has an effect in reducing indoor temperature by about 10%. Next. Roof material is also important both for aesthetic aspect and indoor thermal performance. The figure shows that result of roof material investigation, it was found building with concrete tile roof has the lowest indoor temperature than other roof material. Next. The general understanding of green building in the public refer to the use of plant around the building. We investigate the use of plant on the building wall and found the significant indoor temperature reduction up to 20%. Next. Government building is also become our object of investigation. The investigation of Central Java Provincial Government building by using OTTV found that this building has considered by energy management in its building operation. The energy used is below the Indonesia national standard. Next. Green building research was very booming since 2017. Plant and vegetation were the interesting theme the developed. The green wall had a significant effect on decreasing indoor temperature The application of Dayton's green wall will reduce 6 degrees Celsius compared to usual green wall. Next. In short, the future development for comparing between modeling and simulation research is important to conduct the validation. Investigation about other aspects of green building is also widely open for future investigation. Next. Voila, the pictures show the form of teaching material, book, article, thesis, and dissertation, whose collaboration between researchers in this webinar will be conducted, I hope. Next, step 4. Next, conclusion. First, the reduction model can be a tool for conducting green building study. As far, we still conducting for thermal comfort and energy efficiency. Second, various methods will be very beneficial for development of green building studies. Comparison between methods is an effort to validate the result finding. Third, there are other green building criteria that is very interesting to export. Voila, saya fini. Thank you for your attention. Merci beaucoup.
Thank you, Dr. Eddy Prianto, for sharing us your presentation. I think it's a very nice thing to know that reduced scale of the building can make a research for the effect of the on thermal in housing. So I think the blue stone or green vegetation could reduce the temperature, inside temperature of the house or the building, as far as I saw from your presentation. Okay, we will have the question and answer with Dr. Eddy Prianto later. So right now, I would like to invite, thank you, Tsutsumi Sensei, for joining us today. I'm sorry to bother you with our session. So the second speaker of the second session is Professor Jun Ichiro Tsutsumi from the University of Ryukus. He graduated from Kyushu University for his doctoral degree, and he has the field of research in energy studies, environmental technology, EIA, and also architectural planning. Professor Tsutsumi also a chairperson of Prefectural Committee for Energy Efficient Mitigation and Adaptation for Climate Change right now. And today he will share with us about recent movement of urban and architectural design for SDGs and ESG. So Professor Tsutsumi, please, you can start your sharing your presentation. Thank you.
Okay. Thank you so much, Dr. Edward. Terima kasih and selamat pagi, everyone. I'm very happy to join this meeting. So, may I show my presentation file?
Yes, sure, please.
Yes. Okay, can you see my presentation file?
Yes, Sensei, Yeah, we can see your presentation.
Thank you. So I'm sorry, I have no time to continue this meeting. So I have a next meeting from 1:30. So please allow me the short presentation today. So I want to talk about the recent movement in Japan about the urban and architectural design, especially focusing on SDGs and ESG. At first, the innovation in the world is changing gradually. Of course, I know the 21st century we have facing to the digitalization and decarbonization. It's very important for us to keep the global environment. And also, we can utilize the digital innovation very easily right now, like this meeting. It's an amazing thing. About 20 years ago, we cannot make an online meeting like this, but it's very easy. So this is one big point. However, we have to look back about the buildings or urban structures. Now we are standing at the turning point from the international style to the next step. Maybe almost all the world is facing to the same situation. Maybe they design the buildings in an international style. It's a modernization and also electrification. But recently, we have to look at the much more local situations. That's why the turning point is now. And also we are facing to the very big crisis like COVID-19. Of course, we have a lot of the world crisis from 19th or 18th century. That is the power game. Especially the European countries govern the Asian or African countries. That was imperialism. Also, Japan is one of the members used to be, but right now it's changing. 1989, that was the change of the world. As you know, the destruction of the Berlin Wall. After that, the two big power, one of the two big power disappeared, and populism, racism, or nationalism, was sometimes environmental crisis occurred. Then we need to control the various type of the crisis. And from the viewpoint of building and urban structures, we need a different aspect from the previous age. That is, I think, the environment or social relation or such things. So roughly look back the history of domestic energy. We are using the firewood or charcoals about 150 years ago or maybe 1 century ago. But right now we are using the digitalized electric appliances. It's greatly changed in this century, previous century. So that's an amazing thing. But as you know, the carbon dioxide concentration in the atmosphere is increasing like this. And the world average temperature is also rising. And the swing width is so big. Sometimes we have a very cold season or a very hot season. So that is climate change. And also the very short-term effect of the climate change occurred like this, like a flood or a drought or something like that. So that's why the United States makes the SDGs. 70 goals include various type of the environment or living environment or sometimes the world environment, especially number 6, that is green water, and number 7, affordability of clean energy, and number 9, that is industry or innovation or something like that in the infrastructures. And the important thing is number 11, sustainable cities and communities. So that is one of the big sustainable development goal, and it has very big effect on the urban and architectural designers. And also, who are the stakeholders for the development? Who pay the money for the buildings or urban structures? That is the important thing. The investment is one big factor to develop the countries or some other living environment. So if we work about a public project that is paid by tax, of course, that is coming from the residential people. And also the private projects, that is the owner and the investors. Finally, ordinary people have responsibility for the development. That's why we need the ESG investment. E is the environmental factor, S is the social factor, and G is the governance factor. Social responsibility of developers are very important, including government and municipalities. Also, the ordinary people have the responsibility for the development too. And this is the overlapped slide when I attended the second ICSADU. That was the next generation architecture. We need to understand the 5 Ds. D1 is depopulation. The total population in Japan is reducing. So how to manage the social investment or properties. And the second one is decarbonization. It is well understood, and maybe everyone thinks that a very important factor. And the third one is decentralization. And that's a very difficult to understand, but if we have a very big system to supply the energy or water, sometimes it's big investment. However, it's decentralized. Maybe it's easier to make a renovation. Next one is re-regulation, but I'm not sure it's good or not. Finally, digitalization is an important factor for the next generation. As for the building and the urban structures, decarbonization and digitalization, that's very important. And also we have to consider about socialization, but sometimes it's regularized. Deregularization is not so easy. So it's an image of the smart house. In the near future, we are moving to the building energy management system, and also for the individual houses, HEMS, that is the home energy management system. And we are moving to the ZEB, ZEB, that is the net zero energy buildings or net zero energy houses. Now we have a building code for the ZEB in Japan. Basic theory of ZEB is only the saving energy. Of course, it includes the generating energy too, but saving energy is the first step. And it's a project of ZEB in Japan. ZEB means net zero energy buildings. We have very high energy efficiency buildings to reduce the energy about 50% from the ordinary buildings. And if we can generate the private power in the buildings, like solar power, we can make the energy, net energy consumption zero. There are 3 steps of the ZEB. The first step is ZEB ready. ZEB ready means the just energy saving buildings by 50%. And the next one is the near ZEB. We have to reduce the energy consumption by over 50%, and over 25% should be supplied by the energy generation by solar energy or something like that. And buying energy should be reduced under 25%. That is near ZEB. And the real ZEB, ZEB means totally 100% energy supply by itself. So the over 50% of energy consumption will be saved, and also over 50% of energy generated by itself. That is the ZEB. But it's not so easy. That's why the first step of ZEB, now ZEB oriented, was added right now. It's a 30% reduction of the energy consumption, or sometimes a 40% of energy reduction. So there are 4 types of ZEB now moving in Japan. It's a very short presentation, I'm sorry. But now we have to consider there are a lot of things for the building and urban design, especially environmental factor is one of the most important factor. Especially we are using the buildings and the urban structures or infrastructures. That is the energy consumption. And the energy consumption is directly connected to climate change. That's why we have to consider the energy consumption. And the ZEB is one of the big points for the environmental factor. And also we can utilize the digital factor. How to use IoT or AI in buildings. For example, energy management system, EMS, is one big point for the energy control in buildings or urban structures. So very convenient or comfortable life, but high efficiency and reducing the energy is our final goal. And also we have to consider the social factor. So the technology is advancing and many types of the new innovation occurred. However, it should be friendly to our ordinary life or environment. So that's why the matching to the new movement with traditional life is very important. We need to continue to think about ordinary life and the traditional lifestyle too. Finally, the governance factor, that is depend upon the governmental work or cooperative work. So if you are standing on the administrative side, you need to control above factors, environmental factors, digital factors, and social factors correctly and continuously. So continuous or sustainable development is very important, but sometimes it's very difficult. So that's why the continuous governance is so important from now. So thank you very much. I'm sorry, it's very short presentation. It's my overall view of the new generation buildings and urban design. Okay, thank you.
Thank you, Tsutsumi Sensei, for sharing your presentation and vision for the current and future generation about the green building. The audience to ask questions or give comments for the two speakers. It could be to Dr. Eddy Prianto or Professor Tsutsumi, please. There's a question to Professor Tsutsumi from Dr. Eddy Prianto. In the chat, Dr. Eddy Prianto wrote, smart house principally using electricity to operate domestic tools. Could you give me the reason for the energy saving effort if all domestic works need electricity? Thank you. Could you? Okay. Can you hear me, Sensei?
Yeah. Yeah, so you are asking me about how to reduce the energy consumption, especially the energy directly connected to the building design is the air conditioning and lighting, sometimes hot water supply, such things. Of course, it includes the ventilation, and these types of energy reduced by the performance of the mechanical side itself. So of course, many companies who are producing the electric air conditioning system or something, they can reduce energy directly. However, we have to understand that from the building design, how to use the building materials or something, that's also the important factor. That is the passive design, and also active design is connected together. From these two points of view, we have to make the very good matching with the passive design and the active design. That is my opinion. Thank you.
Okay, thank you, Tsutsumi Sensei. So, Dr. Eddy Prianto thinks that smart house basically needs electricity. So, why the energy saving effort is needed if all. So I think that what Dr. Eddy Prianto means is that we should reduce our activity using the electricity. So as what Tsutsumi Sensei said, that passive design, and one of the effort is also in our lifestyle, like what Tsutsumi Sensei already mentioned in his presentation, is how we should look at our traditional lifestyle in trying to preserve the energy. Okay, I would like to invite for another question from the audience. Maybe Andy, you already turned on your camera. Do you want to ask questions to Professor Tsutsumi or Dr. Eddy Prianto, please?
Thank you. I want to ask question to Dr. Tsutsumi. Before I want to introduce myself, my name is Andi Arifi Caksono. I'm currently doing the research for the PhD program in Erasmus University Rotterdam. And so my research is about also for the climate change, but it's more to proper housing approach to their impact to make the poor can adapt to the climate change. In this regard, I want to ask questions because this also raised an idea in my head that is what you explained before is very suitable to be implemented here, especially in the community. But there's an obstacle that is regarding the price, of course, regarding the items that is we know that it is a bit expensive, but we need it for the lowest society in let's say in my research area in Jogja, and we know that the lowest society in the term of the poor, they cannot afford to buy this kind of technology, let's say, because they are very expensive. So I want to ask whether there in Japan, how the government or probably the policymaker can make this society to be able to buy or to implement this kind of technology. Let's say by probably by the they can provide incentive, like they lower the price or so. That is probably the discussion. Thank you.
Yeah, thank you very much for your good question. I'm also thinking about the price of the energy saving or energy generating system too. So I think that that is why we need to think about ESG investment. If we have some financial system to invest the money for the good design buildings, so if it is the interest is very low or something, maybe it can enhance the better buildings or something. So from this point of view, we need a much more connected system. Not only the technology or not only the engineers, but we have to include the financial system or social system much more. And right now, the Japanese investment system is moving to such a direction. I hope that everyone can understand how to invest the money, and we can get somewhat of the return from the correct investment.
Yes.
That's why that is a ESG. So I'm not sure that is the correct answer for your question, but I think that the connection between the engineer and the financial system is very important.
Yeah, thank you. I think that's answering my question regarding the social, how to touch their social benefit. Thank you.
Yeah, thank you.
Okay, thank you, Andi, for having the questions. So I think for the lowest income, the answer is not have to be a significant tools or gadget or some kind of thing like that. It would be more decent things is already quite applicable to them. So the one who needs the significant building reduction equipment is for the higher. I think
Exactly.
it's good research that you conducting in Erasmus. Okay, good luck with your research. We would like to hear more from your research. Okay. Any other questions maybe from the audience? Maybe from Bu Erni?
Yes, thank you, Pak Edu. My questions will be addressed to Professor Tsutsumi.
Yes.
Hello, Prof. Tsutsumi. How are you?
Hi. Thank you.
It's such a kind of long time no see, because the last meeting with you is about 2 years ago, I think.
Yes, yes, exactly.
We
Yes.
had a dinner with Pak Edu at restaurants in the upper part of Semarang City.
Yes, I know.
Professor Tsutsumi,
Yes.
it's such kind of interesting presentation from you. It's about the SDGs in architectural area and urban design. And I'm interested to ask about the daylight in building, because the daylight aspect has the important role in building conservation, I think, and it's such kind similar between in Indonesia and Japan, but I think Indonesia has much more abundance of daylight because it is Indonesia is located in the equator, but Japan is not. And I think Japan has less in quantity, I think, in daylight, but due to the natural lighting, because conservation energy can reach by saving energy from the electricity used for the artificial lighting, I think. So people can turn off the artificial lighting along the day and only turn on the artificial lighting in the night. So how many percentage the daylight taken into account as a part of conservation energy in Japan? Thank you.
Okay, thank you very much for your good question. Unfortunately, I'm not sure about the daylighting, but I think that not so deeply considered in buildings in Japan, because sometimes the daylight using is a very difficult factor. As you know that inside of the houses or buildings, it's a little bit darker than outside in the daytime. And sometimes the glare or the ratio of the brightness or darkness is very big from outside to inside. That's why it's not so easy to utilize the daylight. So, and also the artificial lighting is very cheap right now because of the we are using the LED mainly right now. So if we compare the energy consumption with the LED system to previous ordinary lighting system, it's almost 1/5 or 1/8 or something. It's very saving energy, right? So that's why we don't think about daylight using not so much, unfortunately. I'm so sorry. It's not my major, but I think the daylight using is maybe it's important factor for the residential houses, but for the office buildings, maybe it's very difficult.
Okay.
Opinion. Thank you so much.
Yeah, thank you, Prof. Tsutsumi. May success be with you.
Thank you.
Thank you, Erni, for the question and Tsutsumi Sensei for the answer.
Yeah, sorry, Dr. Edward. I have to leave now.
Yes, okay. We could understand for your busy schedule. So we would like to thank for your valuable time and sharing your knowledge and experience with us today. So yeah, so see you in the next lecture session
Yes.
in the program. Thank
Yes.
you very much.
Thank you so much.
So
see you.
Okay.
Thank you.
Okay. Bye bye. So okay, I would also like to close this second session for today's event. So we have learned many things from the Professor Erni, from Dr. Acha, also from Dr. Agung and Dr. Eddy Prianto and Professor Tsutsumi. And we saw that there are many things that we could still do related with the green building area, and we should promote these green building topics through research and implementation. We saw many kind of implementation conducted by the speakers today. How Erni make the hexagonal acoustic, and then Dr. Acha with his design, and Dr. Eddy with his model. So yeah, there's still a lot of work that could be done in this field. So, and we also could learn from the past about how to promote green building. So there are a lot of things that we could learn from the past, not only for the higher income people, but also for the lower income people. I think that's all that we could conduct today. So I would like to invite you to give applause to all of the speakers that have been giving their knowledge and presentation for us today. So, okay. So we could close this event. So thank you for all the audience who already joined the third ICSADU 2020 series. Thank you also for the speakers for sharing with us today. I hope that we could learn many things for what have been shared by the speakers today. Thank you very much, and keep your good health in good condition during this situation. Thank you. So please applause for the speaker. Thank you very much. So
thank you Pak Edo, thank you Pak Andi.
Thank you Bu Erni.
Oh iya, apa kabar?
Baik
Terima
Bu.
kasih ya sudah support pada ICSADU 2020. Salam buat keluarga.
Ya, terima kasih Bu. Thank you.
Itu Ardani kok diam aja, gimana tuh?
Terima kasih Mbak Erni.
Iya, Dek Rini, ya nanti segera yang MOU segera deh. Habis ini langsung lari kencang saya ke fakultas ya, Dek Rini ya.
Oh Mbak.
Terima kasih Pak Ade, Pak Supri atas rawuhnya. Terima kasih.
Ya, Bu.